Okay, hi. How are you guys? I'll try to keep this short just in case it screws up. But, you know, I wanted to just kind of show a landscape that's sculpted by fire. It just seems a lot better to actually be out here and looking at it. And I'll get right to the point. What we have here, and, I'm right here near in this area that was actually impacted. One of the few impacts that you can still see are some of the eucalyptus, and I think that's some California sycamore that's actually been kind of knocked back. But otherwise, the ecosystem's recovered really fast, and that's pretty typical of this environment. Everything is well adapted to fire. Otherwise, it wouldn't be here. The other thing, and this is kind of the obvious thing I'm probably thinking about, and like I said, during this fire, campus was evacuated, but you can see that we got the city of San Luis Obispo here, and it's built in this environment that is prone to fire, that is adapted to fire, and where the climate is really, really good for fire. I mean, it's hot today. It's hot and it's dry today. You guys still there, I hope? Okay. So, I think that you kind of knew a lot of those things, but I think that, just walking up here to the P, walking up anywhere around here and getting some relief helps give you some perspective. This is all, it's tens of thousands of people that live in this fire-prone environment. And so there's definitely a lot of ways that fire and fire management affect us and are relevant to what we think is important to talk about. So anyway, that was a lot of work to come up here and talk about this for a couple minutes, and now I feel a little rushed just in case everything dies, which it probably will. And unfortunately, university gave me a new thingamajig, a new hotspot so I could go out and do stuff like this. But man, got a lot of problems. A lot of problems with it. Okay, let's see here. So I've got some more slides, some more stuff I want to just work through here, and I hope that. Yeah, Daniel, thanks for calling me, because I was just kind of like sitting here talking into space, and I was like, right, is anybody there? So
we thought you fell off the P or something. We were a bit worried.
I did almost fall off here, but I didn't. Okay, cool. So you guys got the slide here. Can you see the slide?
Yep.
All right, cool. Okay, so where we left things off last time were about management of forests. Fuels themselves are very they're seductive in terms of a topic, because they're the one thing that we can exert some control over. So agencies, funding sources put a lot of emphasis on that. I mean, in some respects, that's completely practical, because we cannot make it rain. We can't make it rain. I mean, you can't change the wind or the relative humidity. You can't change those things. So, but fuels are the things that we can control. And furthermore, in some forest types, fuel management has been very effective for dealing with wildfire problems. And the case number one is ponderosa pine, and specifically ponderosa pine in the Southwest. These are forests that have regular lightning ignitions. They are a mix of pine and grass. They actually have underlaid by soils that are in the mollisols, they're grassland soils, and fire suppression in these forests. The third ingredient here is fire suppression in these forests has greatly densified them. So just removing the density and introducing regular burning does wonders through these forests, can really change their likelihood of having a damaging wildfire, and just all kinds of really effective management. The one thing I want to caution you about is that ponderosa pine especially ponderosa pine in the Southwest, is not every forest. And there's a danger in thinking that it's as simple as just cutting trees and adding fire. It works in ponderosa pine in the Southwest. There's a lot we can learn from it. And some places it might be that simple, but I think it's going to be more, a lot of our problems are different and more complex. So let's look at some of those. In the Coast Range, the combination, there's lots of heavy fuels in the Coast Range, and some of that is a reflection of species characteristics like this resprouting, which is very common. Past harvesting has contributed to densification, and so has diseases and some other things. There are places where fuels treatment could help, and this photograph is of one of those, just a stand that's so dense that you got to do something in there. But it's so dense that it's really hard. There has to be a lot of preparation before you could burn it. So, and in particular in the Coast Range, that's why you may have heard this, you may have this in some of your classes, discussion about mastication, just going in and breaking down these materials, mashing them down or grinding them up in order to change the dynamics of wildfire. That's not necessary in the Southwest. In different, now, it doesn't happen, it doesn't work that way in the Southwest because the dominant overstory species doesn't resprout. So you don't have the same ecological dynamics, and therefore the solution is different. Now look at the Sierra Nevada. Here's another forest ecosystem that's been greatly impacted by fire suppression. This is a photograph from the Rim Fire, which burned really hot, burned at mid-elevation, areas where the Sierra Nevada has the most biomass, burned really hot, and in particular, it burned in areas where there had been extensive fire suppression, and there had been a shift from fire-resilient species to more fire-susceptible species. Those fire-susceptible species may also have been just simply more flammable. So, that caused a lot of problems. And the solution here is at least probably going to be removing those fire-susceptible species. Those are the true firs, and changing forest structure in some way so that it's more resilient to fire. The density and biomass, what's the right density? What's the right biomass for these forests? How do we make them fire resilient? We don't know. We don't know the answer to that. I hope you try to figure it out, because it's an important question. Okay, so post-fire, something that's done a lot is salvage harvesting, and this is a photograph from the Klamath Mountains. Klamath Mountains are yet another example, a different example of fire dynamics and fuel dynamics in California. The Klamath is sort of in this area where it's fire prone, a lot of fire adaptation, but you have something that is kind of like the Coast Ranges, but also kind of like the Sierra Nevada in terms of its ecology. You have resprouting species, non-resprouting species, lots of diversity, and it's just really complex ecologically. But it'll burn hot, and one of a useful thing to do, a good idea after a big fire, especially in areas with a lot of timber, is salvage harvesting. And that's useful at least because if there's valuable timber in a stand, you can at least get it out. The problem with salvage harvesting is that it's actually expensive. It usually only stays in the black, is revenue positive if it's subsidized. That's not always the case, but it's often the case. And you have to get that wood fast, otherwise it will rot. And you might have to harvest areas that you weren't planning. On top of that, the mills will get a ton of wood all at once. That sometimes often does overwhelm their capacity really quick. So it's not a silver bullet. Here's another example from the Coast Range, this Boggs Mountain. It's this area where it's actually a Coast Range that's dominated by ponderosa pine. And this is just an example, I think, of where salvage harvesting is a good idea. This area burned really, really hot in the Valley fire and the Valley 2 fires. 100% mortality in most places, and it was a dense stands anyway, and now there's just like lots of fuel and just wood, and that's going to come down into these forests. Salvage harvesting here, particularly salvage harvesting and then retaining whatever live trees you can, is renewal. There was some revenue generated out of this. You can see the stumps, lots of cutting, and there are some potential positives that are going to come out of this. Just renewal, and I wouldn't be surprised if it's faster establishment of the overstory. This is a state experimental forest, so these are research questions. You know, how effective is salvage harvesting for renewing the stand, restoring it? So,
I had a question.
Please.
Going back to when you mentioned that we've gotten more fire intolerant species in coast ranges because of fire suppression. Why is that?
Why? Yeah. So in the Sierra Nevada, at least, we've gotten more fir because fir has a higher shade tolerance. It's more shade tolerant. So in dense stands, it grows better than some of the less shade tolerant species. And the less shade tolerant species also tend, at least in the Sierra Nevada, are those which have tend to be more fire resilient, like ponderosa pine. In the Coast Range, it's a little bit more complicated. It actually just depends on what part of the Coast Range we're talking about. And a lot of it seems that the fires have just gotten more intense, but species composition hasn't really changed that much. Big Sur is the what I would point to there, where we've had really hot fires, and the only thing that seems to be different than, let's say, 100 years ago is that the landscape is denser. Overall, more shrubland, more forest, more denser forests, and less grassland. In Sonoma as well, one of the big changes in Sonoma County since 1920 has been the loss of grassland. And Sonoma's actually seen some loss of chaparral, but in general, loss of grassland, and it's been converted to forests. And of course, those areas seem to have burned even more intensely during the Sonoma wildfires of 2017 also. So, and that example of the Coast Range is just a landscape level intensification, vegetation, or what else should I say? Increased density of vegetation. Cool. So there certainly is a role for direct attack with California wildfires. They threaten lives and property. Sonoma and the campfires are, case number one in tragedies, wildfire tragedies. There have been several others. But I think in the first and foremost in our minds here in California, they cost billions of dollars in damage and loss of significant loss of life. So it's very tragic. So there is absolutely a role for direct attack in wildfires. It can help reduce the area impacted. We could save housing and structures and lives. And so, definitely, protect areas from burning where we might not want them to burn under the conditions that they're in. But it is very expensive. It is very expensive. These big aircraft that CAL FIRE has is really impressive to see it fly over, and it can drop a lot of retardant, but it is expensive to operate. The crews themselves are expensive, and they put human life in hazardous positions, and oftentimes this is to protect you know, homes and structures that are out in the wilderness. Here's an example from above San Diego. This is near the town of Julian, where it's pine dominated, Jeffrey pine dominated actually, and you've got people that live out there, which is it's their land. But you know, we need to be honest here. If these homes are insured, and if we're going to use state resources to combat wildfire around them to protect the resources, we're talking about state tax dollars being used to subsidize people living out in these wilderness areas. And there's some real questions, you know, that come up with that. I'm not going to say one thing is right or wrong. I should run people off their land. I really don't want to see that. But like I say, it's the problem is there. And the other thing to kind of keep in mind is just that fuels conditions are dynamic and that they can change. This is an example from Curry County, Oregon. The forest type is pretty similar to what you find in Del Norte County. Pretty dense, pretty wet, but seasonally dry. There've been some major fires in these areas. This is near the town of Brookings. And all the gray canopy you see there is from sudden oak death. So all these trees died in just a couple of years, and that greatly changed the dead fuel levels in this particular forest. I mean, it just happened in a matter of a few years. It's a real big mess. And like I say, fuels conditions can change really rapidly, and then there are these examples, various tragedies. This is the Man Gulch fire. This is Man Gulch, and it's the location of the Man Gulch fire, which killed 15 or 16 smoke jumpers in 1946. 1946 or 1948, you know, right at the beginning of the smoke jumpers being a thing, you know, people jumping out of airplanes to combat wildfires. And if you don't know that, if you're interested in fire, if you think you're going to work in fire, it's worth reading the book Young Men in Fire. What's the guy's name? Norman. I'm blanking. He wrote, same guy that wrote A River Runs Through It. Anyway, this is a really interesting discussion, or a really great analysis of this tragedy. It was a crew of 18, and 3 people survived. Just an important an important thing to study in terms of how to protect the lives of the people who are working in these areas. This is basically what happened is the fire ran up this canyon really fast and overtook the smoke jumpers. This is on the river that you see here is the Missouri River. This is in Montana, and the topography here forced air up canyon. And that is why that, with lots of grass and lots of fuel and the overstory, the fire overtook these firefighters.
Hey, Richard?
Yes.
It looks like you might have a student in the waiting room.
Oh, no. Where are they? Let me see. Really? Can you get him in? Huh. Okay, hold on, everybody. Oh, geez, what a mess.
I think there's a way you can just disable the waiting room and people can just get in from the.
Oh, yeah. Let's see. Okay. I've disabled the waiting room. Are they in there? I think they left.
Yeah, I'll
Not
let them
sure.
know.
Okay, thank you.
Thank you.
Sorry about that. Okay, I'm going to go back. Oh, geez. All right. Anyway, Man Gulch Fire and Young Men in Fire. It's a good book. So how do we understand how wildfire dynamics work? We can actually study them in the lab. there's a really great facility up at Humboldt State, burn table, you know, with just simple ovens and, you know, that kind of laboratory equipment, you can manipulate. You can manipulate relative humidity. You can manipulate fuel moisture and that stuff. And then you can burn this material in the lab and measure the amount of, you know, the energetics, the flame length, the heat release, the burn time, total energy released. And it's easy to manipulate moisture and stuff. You can do this with wood. All these are factors that they all vary among species. So they give you some, by doing these kinds of experiments in the lab, you can understand how changes in forest structure will potentially affect wildfire dynamics. And you can simulate the effects of differences in weather. So that, you know, these burn table experiments are really handy. And this is just some examples of what it looks like. You know, there's basically a ruler behind that material that's being burned. And this guy, Mike Jones, who works for UC A&R now, he's just watching the smoldering stuff and waiting to, you know, record the time and how long the material smolders. It can also be done with remote sensing. And these are really helpful too, because you can make maps of fire intensity in large areas. This is for the Basin Fire in 2008, Big Sur. You know, direct measurements of fire energetics are in development. We hope that we'll be able to get some of that from satellites. The technology is moving forward to do that. Fire intensity itself the units. I don't know if you've encountered this, but it's usually measured in units of watts, which are a measurement of work. Measurements of work. So they're joules per meter per second. And what that is saying is you don't measure it on a per area basis. You measure it as the intensity of the fire line in that moment in time. And when you have a fire that burns for weeks or months, all kinds of factors that influence its intensity are going to vary. The temperature, the relative humidity. Some areas are going to burn at night. Some areas are going to burn during the day. You know, it's very complex. It's not all burning at the same intensity, and that's why when you look at an area that has burned, you'll see different severity of burn depending on where you look. The good news is that you can measure fire intensity and impacts remotely with decent accuracy. This case has got a pretty high correlation between them. And, you know, as this technology develops, I think it'll help us understand what we're confronting even in the moment. So, and this is maybe surprising, but fire intensity and fire impacts are different things. So fire intensity is usually an issue that we confront if you're trying to actually combat these things. If the fire line is really intense, it may not be safe to send people out to combat that because of a risk to them, or it's just too hot, basically. But the impacts, oftentimes we're talking about something different, and that could be this. This is a measure of sort of an attempt to make a comprehensive measure of impacts to the vegetation and the soil. But it's a hard thing to kind of do, and oftentimes we find that certain parts of a burn index are correlated with intensity and certain parts are not. Like I say, a long burning fire, it'll go through a lot of different dynamics. And one of the important problems is that, especially in areas with a lot of fuel buildup, the intensity may never actually reach that great. But if those areas burn for a long time, especially in the interior of a fire, the impacts can be substantial. Here's a photo that I've shown before, an area that burned for quite a long time, had a lot of wood in it prior to the fire. And you know, the impacts here are kind of what you expect, lots of vegetation being burned up and killed, but you have other kinds of effects that are maybe more associated with how long the area burns. And that could be loss of soil structure that I've mentioned before, and also loss of regeneration potential and loss of soil structure. So here's an interesting example. This is from Big Sur, where there's a lot to walk through here, but what's happened here is that areas that have accumulated a lot of ground fuel have higher burn impacts in redwood stands. So what this study showed was that in areas that in 2008, in the 2008 basin fire, that areas that had lots of dead fuel on the ground prior to the fire, you have increased mortality of redwood. So, you know, as much as like 20, when you have a fire in a redwood stand, typically all this, you know, if it's an intense fire, it's going to kill all the small trees, everything under 20 centimeters in diameter. But if you have lots of fuel accumulation, that mortality threshold can increase all the way up to 50 centimeters in diameter. And that's a big tree. A fire that removes everything under 20 centimeters versus one that removes everything under 50 centimeters in diameter are very different. And that's going to have a long-lasting effect on structure, and maybe even changing forests in some way that we don't want. So that's just a photograph of this area that burned, and I was just wanted to use that as a segue just to show you some data demonstrating that the same thing happens. The same effects happen with soil impacts here, and this is just carbon, and this is the amount of fuel accumulation here on the x-axis, and you can see that in areas, both of these forest types, redwood and mixed evergreen, the areas that had less pre-fire fuel buildup retained more of their soil structure and nutrients, and possibly enough to make a difference, you know, long-term in terms of ecosystem recovery. This is my work, and part of my ongoing work here at Cal Poly is to follow up on this and see what happens to the above ground vegetation. Here's just another picture of this area. And I've been pointed this stuff out before, but just for completion, you know, post-fire loss of soil structure erosion, increased runoff can be really problematic, and it can cause a lot of damage. And here's just some other examples, you know, and I don't know if I mentioned this before, but this post-fire runoff it's pretty silty, it's pretty basic, has a lot of nutrients that if you could keep them on site, it might help to retain forest, or, you know, aid in post-fire recovery. Okay, so that's kind of the fire bad kind of part, but you know, fire is a complex thing. It's a complex issue. It's a complex event. It's complex ecologically, and fire in fire-prone ecosystems is also a source of renewal. Even intense wildfire can be a source of renewal. It affects regeneration, creates habitat, definitely cycles nutrients. Even when there's a lot of nutrient runoff, still takes organic nutrients that are bound in organic matter and then transforms them into an inorganic form. And that can actually have some positive effects, can accelerate nutrient cycling. And when you look across the whole of California, the whole of our cultural diversity and our management diversity, fire is the traditional management tool in our indigenous communities, and it's increasingly an issue of sovereignty in autonomous tribal communities. It's part of the worldview. It is, you know, people grow up with stories from their grandparents that forest structure was different and that it helped with acorn collection and other problems that these communities are facing now. And I would say that in terms of leadership in getting fire out on the ground, I really can't see a better group than a lot of the tribal forestry agencies in doing that. They're getting more stuff burned, and they're just getting more of it done. And I think that is a reflection of the culture, you know, just a shared values that getting fire on the ground is important for the longevity and resiliency of these communities. It's pretty cool. You go up there and it's young people talking about fire and talking about collecting acorns, and it's a good scene. And here's an example of a site that's actually being managed with lots of burning and careful cutting for the various forest resources that are associated with fire, including acorns and some other things. Well, all right. I'm gonna stop sharing and see. I think I got through my material before everything died. And